Have you ever really stopped to wonder how an AI gets you? I mean, how it actually understands what you're trying to say? It's not just about matching keywords. It's about grasping the real meaning behind them. Well, today, we're going to unlock that secret language. And our key? It's a really cool tool called ChromaDB.
So think about it like this for a second. How on earth does a computer know that when you say, "I'm craving an apple," you want a piece of fruit, but when you say, "I'm investing in Apple," you're talking about a tech giant? It's all about context, right? And for the longest time, teaching a machine about context has been one of the biggest hurdles in all of AI.
So to crack this code, AI couldn't just rely on letters and words. Nah, it needed a totally new way to represent the world, a kind of universal language for concepts. And what's the most universal language we have? You guessed it, it's math.
And that brings us to this idea of vector embeddings. Now I know, it sounds super technical, but stick with me, because the concept is actually pretty simple. Just imagine a giant, invisible map of literally every idea you can think of. On this map, every single concept, a word, a sentence, heck, even a picture, gets its own unique set of coordinates. So the word king is right next to queen, and puppy is super close to kitten, but something like car is way, way over on the other side of the map from philosophy. That coordinate, that address for an idea, that's an embedding.
Okay, so we've solved one problem. We can now represent meaning with numbers. Awesome. But in doing that, we've created a whole new challenge. This idea map is absolutely enormous. We're talking billions, maybe even trillions of points. So if you ask a question, how can an AI possibly scan that entire map in a split second to find the closest, most relevant answers?
And this is exactly where our hero of the day, ChromaDB, steps in. You can think of ChromaDB as a specialized, high-speed GPS for this map of ideas. It's an open-source vector database built to do one thing and do it exceptionally well: navigate this huge numerical space and find exactly what you're looking for at lightning speed.
And here we can see the whole thing in action. It's like a little assembly line of intelligence. An app gets a question from you, the user. That question is immediately converted into a numerical coordinate. Yep, an embedding. Chroma then takes that coordinate, zips over to its library, finds the most similar documents it has stored, and hands that super relevant context over to a large language model. And the result? You get a smart, accurate answer instead of a wild guess.
So what's the secret sauce here? What makes ChromaDB so good at its job? Well, first off, it's a total powerhouse for storing and searching through these complex vectors. But you know, its real strength, the thing people love about it, is just how simple it is to use. The API is clean, so developers can get up and running in no time. It's flexible enough for a little weekend project or a massive production system. And it plays nice with all the popular AI models from places like Hugging Face and OpenAI that everyone's already using.
Okay, so we've seen the big picture. Now let's pop the hood and take a look at the step-by-step journey your data takes inside ChromaDB. We're going from raw information all the way to some powerful discoveries.
You know, the process is actually pretty logical when you break it down. First, your data, whether it's documents, images, whatever, gets turned into those numerical vector embeddings. Second, those vectors are stored neatly in what Chroma calls a collection. Third, when you ask a question, your question also gets turned into a vector, and Chroma uses that to find the closest matches. You can even add filters to narrow things down, and finally, Chroma brings you back the most relevant results. Simple as that.
And you might be thinking, this must just be a chaotic mess of numbers. But nope. To keep everything tidy, Chroma uses a really clear hierarchy. At the very top, you have a tenant. Think of it like an organization. That tenant can have multiple databases for different projects. Then, each database holds collections of similar items, and inside those are the individual documents with their embeddings. It's like a perfectly organized digital filing cabinet for ideas.
All right, theory is great and all, but seeing is believing. Let's take a look at a really quick code example to see how this actually works. Now, don't get hung up on the syntax here, just focus on what this one line of code is doing. After we stored a few documents, we ask our question. We're basically telling the collection, hey, can you please query yourself with this text about machine learning and data science, and just give me back the top 2 results. This single command, this is where all the magic happens.
And here it is, the payoff. The system comes back with the 2 documents that it stored, one about machine learning and the other about data science. And notice what it did. It didn't just match the words machine learning. It understood the semantic meaning, the vibe, if you will, of our query and found the concepts that were closest on that giant idea map. That is the power of this whole approach.
So now that we kind of get the how, let's talk about the why. Why does any of this matter? What kind of real-world magic does this technology actually unlock for all of us?
The applications here are huge, and you've probably already used them without knowing it. This is what powers semantic search, when you can search for an idea instead of just an exact phrase. It's the engine behind recommendation systems that somehow know exactly what movie you want to watch next. It's also critical for something called Retrieval Augmented Generation, or RAG, which is basically how we give chatbots access to new, up-to-date information so they don't just make stuff up. It can even be used for things like anomaly detection, instantly spotting the weird one out in a massive pile of data.
But, of course, no tool is a silver bullet. Nothing is perfect. So to really get the full picture, it's super important to look at both the strengths and, the limitations of a tool like ChromaDB.
So on the one hand, its advantages are crystal clear. It's scalable for a ton of use cases, it's flexible, it's incredibly easy to get started with, and it's got a fantastic open source community behind it. But on the flip side, it can be pretty hungry for memory, and for truly massive enterprise-level data sets, there might be more specialized tools out there. Plus, indexing a very, very large amount of data can sometimes take a while. It's all about trade-offs. So, what's the big takeaway here? Well, we've figured out a way for machines to navigate the unbelievably complex map of human meaning. And tools like ChromaDB are the GPS systems that make that navigation possible, fast, and accessible to everyone. And that leaves us with one last fascinating thought to chew on. Now that machines can truly understand our world of ideas, where do you think they're going to take us next?